Hi, welcome to Pre-Calculus. Today we're going to do notes on Chapter 2.3, Day 4. We're going to be talking about the real zeros of polynomial functions. So go ahead and make sure you write your first and last name and what period you're in for me. All right, so we're going to learn about something called the remainder theorem today. And it says this fancy wording that basically if a polynomial is divided by y minus k, the remainder r is the function of k. The remainder theorem tells us that synthetic division can be used to evaluate a polynomial function. So we're going to take the polynomial 3x cubed plus 8x squared minus 2x plus 4 at x equals 4. This just means that 4 is going to be the number in your little box over here. Okay, so you're going to do the same as you did for the synthetic division, and you're going to take all the coefficients, and if you're missing one, just go ahead and fill in a 0. So we're not missing any, right? 3, 2, 1, 0. Okay, so our coefficients are 3, 8, -2, +4. All right, and then we're just going to bring down the 3, then we're going to multiply. 4 times 3 is 12, then we're going to add 8 plus 12 is 20, then we're going to multiply. 4 times 20 is 80, then we're going to add -2 plus 80 is 78, then we're going to multiply. 4 times 78 is 312, and then we're going to add 4 plus 312 is 316. So then you just write your answer like this. The function at 4 is equal to 316. Now we're going to talk about what to do when they ask you to list all of the possible rational zeros of a polynomial. Okay, and that's how the directions for most of these are going to be worded. List all of the possible rationals of the polynomial. So for the polynomial, 3x to the fourth plus 3x cubed minus 12x plus 14, we're going to write a p and a q, where p is the factor of the constant term. The constant is usually the last term if it's in a standard form, and it's when you have x to the 0 power, so there's no x here. And the q is going to be the factor of the leading coefficient. So the first term, as long as your polynomial is in standard form. So just make sure it's in the correct form first, and then it's basically the p is the last term, the q is the coefficient of the first term, and then you're going to list all the possibilities. So all the factors of 14 are 1 and 14, because 1 times 14 is 14, right? And 2 and 7, because 2 times 7 is 14, and then plus minus of all of them, because it could be positive or it could be negative. Okay, and then in the denominator, we're going to list all the factors of q. So q is the leading coefficient, which is 3. And luckily, there's only 2 factors of 3, which are 1 and 3, positive, negative of both. Okay, so we're going to write each of these as a fraction. So start with the easy ones first, where when you have 1 as a denominator, it's just whatever's in the numerator. So 1 over 1 is 1, 2 over 1 is 2, 7 over 1 is 7, 14 over 1 is 14. So those first 4 should be easy. Okay, now we're going to do fractions with 3 in the denominator. So 1 over 3, 2 over 3, 7 over 3, 14 over 3, plus minus of each of those. So when they say they want all of the possible rational zeros, you're going to list all of them out. Are they all going to work? No. Okay, so, but that's all the possible factors. Okay? So when the directions tell you to factor completely, you're going to list all of the possible rational factors that are 0, and then you're going to try a couple of them and see what factors you can come up with. So for x cubed minus 21x minus 20, the p's are going to be all the factors of 20. So 1 and 20, 2 and 10, 4 and 5, and you'll see all those in there. And then the only leading coefficient here is a 1, so everything over 1. So that one, all the factors are pretty easy. So you're going to try one. Let's try -1. Okay, so we're going to bring down, well, first list all of your numbers for your synthetic division. So we're missing the x squared term, so I subbed a 0 in there. So we've got 1, then we've got 0, then we should have negative 21, and then negative 20. So we're going to bring down the 1, then multiply. Negative 1 times 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is positive 1. Then add negative 21 plus 1 is negative 20. Then multiply. Negative 1 times negative 20 is positive 20. And then negative 20 plus 20 is 0. When you get a remainder of 0 like this, you know that it is one of the rational zeros. That means that you need the binomial that's going to get you negative 1. So if we plugged a negative 1 in here, negative 1 plus 1 would be 0. So that's our first factor. And then this should give you the trinomial x squared, because remember, you subtract 1 from here. So x squared minus 1x minus 20. And you can do synthetic division on this, but this one is easily factorable to x minus 5 and x plus 4. So let's try a slightly harder one. So for this one, we have 2x cubed plus 13x squared minus 13x minus 42. So in the numerator, we're going to put all the possible factors of the constant term, which is 1 and 42, 2 and 21, 3 and 14, 6 and 7. And then, since our leading coefficient is 2, our possible factors are 1 and 2. Okay, so we're going to see which ones might possibly work. So let's try 2, because 2 over 1 is 2. Okay. So let's bring down the 2. 2 times 2 is 4. 13 plus 4 is 17. 2 times 17 is 34. Negative 13 plus 34 is 21. 2 times 21 is 42. And negative 42 plus 42 is 0. So we know this one is a factor. So if we take this 2 and plug it in here, we get 2 minus 2, which is 0. So we know that x minus 2 is our first binomial factor. And then we subtract 1 from this exponent, which is squared. So 2x squared plus 17x plus 21. And this one looks a little hard to factor, but if you multiply 2 times 21, x squared, you get 42x squared, which factors to 3x and 14x. Okay, to get that 17x in the middle. Okay, and then the GCF here is x, so we factor out an x. That leaves us with 2x plus 3. The GCF here is 7. Factor out the 7, you get 2x plus 3 again. So if you have 2x plus 3 and 2x plus 3, that's one of your binomials. And then the x plus 7 that's left over is your third binomial.